Hey K-12 educators, welcome to this explainer. I am absolutely thrilled you're here. Today we're diving deep into a tool that is seriously shaking up how we approach high school science. It's called the sample. And my goal today? We're going to unpack exactly what this simulation is and how it literally transforms everyday classrooms into rigorous, highly functional crime labs. So, let's jump right in.
So here is the million-dollar question. How do you make students actually think? Not just memorize facts, not just go through the motions to get a grade, but genuinely engage in complex thought. Look, as teachers, we all know this struggle, right? We are fighting for their attention every single day. We want them leaning in, asking questions, digging into data. And the absolute genius of the resource we're exploring today is how it tackles this exact issue by flipping the script from passive learning to active, high-stakes decision-making.
And it all stems from this one powerful core philosophy. The sample doesn't care who you suspect. This motto is stamped on every single lab report the kids handle. It sets the tone perfectly. We're dealing with hard science here. Not rumors, not bias, not what everyone assumes happened. The entire simulation is built from the ground up to teach students to prioritize raw evidence over a convenient, easy narrative.
To pull that off, we have to completely change the environment. We have to welcome them to the lab.
So how does the sample actually hold their attention? Well, it's a 10-day data interpretation simulation. You take your class, break them into teams of 4, and here's the kicker. They don't just act like students doing a group project. They actually take on real biotechnology job titles. They literally become lab technicians. For about 2 weeks, they're handed 3 specific cases. And they aren't just reading a textbook chapter about forensics. No, they're doing it. They're analyzing DNA profiles, checking controls, and they are the ones making the final official calls. When this kicks off, your standard classroom transforms into the Meridian County Regional DNA Laboratory, and the source material highlights this amazing phenomenon that happens when you do this. The room actually goes quiet. It goes quiet because it suddenly hits them that this isn't just theory anymore. These cases are theirs to solve. They own it. That mental shift from a student just chasing a grade to a professional lab tech trying to crack a case, that is exactly how you captured that elusive focus.
And that brings us to the actual work they'll be doing. The real decisions they have to make across 3 distinct cases.
Each of these cases is designed to look like a slam dunk at first glance. Take case 1, for example, the intake. The expectation is super simple. The fancy lab machine spits out a big, bold, confident match. Now, in a normal school setting, kids would write down match, pack up their bags, and ask for an A. But the evidence tells a completely different story. If they actually check their scientific controls, they'll notice that a control that's supposed to be completely empty actually has DNA in it. What does that mean? Contamination. The rigorous, scientifically accurate call isn't to report a match, it's to void the entire run. They learn right out of the gate. You have to trust the controls over a machine's confident output.
Then, things get a bit more complex in case 2, the elimination. The expectation here leans heavily on social pressure. Basically, the whole town knows who committed the crime. The narrative is totally baked in before the file even hits the desk. But if the students read the evidence honestly, they discover a single chain of custody log that breaks the entire story wide open. Plus, the DNA profile flat out excludes the popular suspect. It's just a brilliant way to show them the power of unbiased, careful reading to completely dismantle popular assumptions.
And finally, case 3, the call. This one brings the emotional pressure. A grieving family desperately wants a name. They want closure. But the evidence? Well, the DNA sample is just too degraded to accurately identify anyone. So the lesson here is tough but crucial. Students learn that sometimes the bravest and most scientifically rigorous answer they can possibly give is simply, the evidence is insufficient. They learn that in the real world of science, we don't know yet is often the absolute strongest, most honest conclusion you can draw.
Which leads us to the critical thinking payoff of this whole experience. Why does all this matter? Well, traditional schooling is great at transferring knowledge, but it rarely trains kids on how to use that knowledge under pressure, because every single case in the sample ends with them making a definitive, high-stakes decision. Real thinking has to happen. They're practicing evidence discernment, right? Separating fact from fiction. They're engaging in ethical reasoning when the whole town wants one answer, but the data says no. They're practicing emotional regulation and metacognition, literally thinking about how they think. This is exactly how we train young adults so they don't just freeze up when a difficult decision is ultimately on their shoulders.
And hey, for the science teachers out there, you can absolutely rest easy about the authenticity of this. The simulation uses real DNA markers and real lab controls identical to what's used in actual forensic labs.
Plus, because every student has a real job title for those 10 days, you're seamlessly weaving a career exploration unit right into the science curriculum. It's a win-win.
Okay, let's pivot and talk about the practical side of things, because logistics matter.
It is fantastic to have a highly engaging simulation, but as a busy educator, you're probably thinking, okay, what's the catch? How hard is this to implement? The answer is 0. For grades 9 through 12 Intro Biotechnology, there are 0 prerequisites for the students and 0 expensive lab equipment for you to buy. Since this is fundamentally about data interpretation, it doesn't replace your hands-on wet labs. Actually, it makes them way more valuable because your kids will finally understand the analytical side of the data they're generating in class.
And grading, this is completely crucial. Students are graded on the quality of their decisions, not luck. A team that uses sound logic to arrive at a frustrating but honest, insufficient conclusion will literally outscore a team that just guessed and got a lucky match. It completely shifts the classroom paradigm from just hunting for the right answer to actually proving your work scientifically.
Honestly, this is a fully classroom-ready package. You get a teacher guide with completely scripted daily plans for all 10 days, every single evidence file the kids need, and all the grading rubrics. Best of all, it includes formal, editable lesson plans with a teacher evaluation crosswalk. You could literally pull one of these days and use it for an official observation lesson and absolutely nail it.
So, if you're looking to bring this kind of engagement and rigor to your science classes, the next step is simple. Head over and browse the collection at Patience Learning to bring this Meridian County DNA lab experience straight into your own room.
I really want to leave you with this final provocative thought. What does critical thinking look like when students can't even tell they're doing it? Well, it looks exactly like the sample. They'll completely forget they're doing a school assignment, but they will never stop actively thinking, analyzing, and debating. Thank you so much for joining me for this explainer. I really hope this deep dive into the source material sparked some ideas and gave you a clear, actionable way to empower your students. Keep exploring and keep making learning fascinating.